Mr. B, and during this short lesson, I will explain how to determine the formula mass or molar mass of an ionic compound. Let's begin with a simple compound, sodium oxide, Na2O. When determining the formula mass or molar mass of a compound, always refer to the periodic table, where on the periodic table we find all known elements. Now, in the box containing the Na, or sodium, we find, first of all, the symbol, we find the charge number, and many other things. However, what we're interested in here is the average atomic mass. The average atomic mass of sodium is 23. Now, in the 23 grams. Now, in the molecule, there are two sodiums. There are two. Two applies to the Na only. So we multiply 23 times 2 for a total of 46 grams. So there are 46 grams of sodium in a mole of sodium oxide. There's also one oxygen for a mass of 16. Remember, we take the rounded mass. 1 times 16 is 16. So we now add the two values, and the formula mass or molar mass for sodium oxide will be 62 grams per mole. Okay. Yeah, that was pretty simple. That was very simple. And so it's always better to start off with a simple example before you do more complicated examples. Speaking of complicated examples, let's try another. Let's try determining the molar mass of barium hydroxide. Okay, now clearly this formula has a parenthesis. We can't deal with parentheses, so we must eliminate it. We eliminate the parenthesis by distributing the two. BaO2H2, great. Now, from the periodic table, the rounded mass of barium is 137 grams. And we have one barium. The rounded mass of oxygen is 16 grams. But we have two oxygens. The rounded mass of hydrogen will be 1 gram. But we have two hydrogens. So we write 1 times 137, 137. 2 times 16 is equal to 32. So we have 32 grams of oxygen in the compound. And of course, 2 times 1 is 2 grams of hydrogen. Now we add them up. And the total will be, the sum will be 171 grams. And since this represents a mole of barium hydroxide, 171 grams per mole. Now, as a final example, another example that's a little more complicated, just a little more complicated. Iron 3, carbonate. All right, that's a formula for iron 3 carbonate. This formula has 2 irons, some carbons, and some oxygens. We'll get to that in a second. But first things first, let's eliminate the parentheses. To eliminate the parentheses, we distribute the 3. So we write Fe2C3O9. Okay? Now there are 2 iron atoms in the formula, or 2 moles of iron, where each iron has a mass of 56 grams. Okay? There are 3 carbons. 3 times 12 grams, and there are 9 oxygens. 9 times 16 grams. So the product here will be 112 grams of iron. Here we have 36 grams of carbon, and here we have 144 grams of the oxygen. Okay? Add them up, and the total will be 292 grams per mole. And that essentially explains exactly how to determine the molar mass or formula mass of an ionic compound. Thanks for watching. See you later.